Alright, this is LeetCode 11. It's called Container with Most Water. So the prompt says you're given an integer array, height of length n, and there are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height of I. They want you to return, or they want you to find the two lines that together with the x-axis form a container such that the container contains the most water, and then return the maximum amount of water a container can store. And then notice that you cannot slant the container. Okay, so this prompt is honestly kind of confusing, so they provided us with some pictures. Sometimes though, in some of these interview questions you might not get these pictures, so it's good to try to maybe practice on your illustrating skills based on the description. Okay, so here's the example 1. So we're given the input array. It's just these integers called height, and this picture represents our height array, right? And as it says here, they want us to return the maximum amount of water a container can store. So basically, if you think of this being like a bucket, they're saying that we would return 49 because the two tallest and the widest, basically that we maximize the amount of water that we can store. The two lines that maximize the amount of water that we can store are these two lines right here. One of the lines is at 8 and the other line is at 7. It's the lines in red here. And because this one's at 8 and this one's at 7, that would mean that in total the height of both of these lines, basically like the limiting factor is the smaller line, right? Because you can't slant the containers. So if you would fill this up to 8, then the water would spill over here. Let me go ahead and use a little color thing. The water would spill over here if we filled it up to 8, right? So, and these values are 7 apart. So it's not like in real life, I think volume's like with 3 variables, but since we're just doing like a 2D picture, we're gonna do the height is basically like 7, right? And then the length is 7, so that's why we would output 49, right? And that happens to be the maximum out of all these lines, all these possible options. So like this option here, this one that goes up to 1 and this one that goes up to 8 would produce, obviously the only amount of water that I could hold would be this, and this is a lot smaller than this big blue piece of water, right? So this is the option. These are the two lines that maximize the amount of water that we can hold. Hopefully that makes sense. I think they kind of summarize that in the description here, so let me get rid of these. Yeah, in this case, the max area of water, blue section, the container can hold is 49. And then they give an example of if we just had 2 lines that was 1 and 1, that would almost be like a picture where we have a line going up to 1 here and a 1 here. So the height would be 1, and then the width would be 1. So 1 times 1 is 1. So that's how much water we could hold in that particular bucket, which happens to be the maximum. Okay, oops. Trying to get this back. Give me a second to figure this out. All right, we're back. So let's go ahead and talk about how we can actually solve this. So, so obviously, there's a naive solution, and there's like a more optimized solution. That's usually always the case with these LeetCode problems. So the naive solution would be so you're given an array, right? And these values, this 1 represents 1 bar, this represents that, this 8 represents that, this 6 represents that, and so on. Like these are what represent these values or these lines, right? Or if you can think of like the left and right part of our bucket. So a naive solution would be just to have like a double for loop and just go through every possible combination of basically every possible combination of these left and right lines. So we can have like a left line here, or like a left, and then we check right, and then we move right all the way through here, and then we'd move left to 8, and then check for right all the way over there, like for every combination, and then we just calculate the amount of water that it could hold, which is basically, it'd be a pretty simple operation. It would just be like we would get the minimum of the left and the right lines, and then calculate the width, which is basically the difference, or like the distance that the left and the right lines are, and then we'd multiply that, and then we'd get our value. And we would do that for every possible combination, and then eventually we would just keep our whatever was the maximum value, right? So this is the naive solution. This is more of a brute force solution. This solution would be O of n squared time, because you're doing a double for loop and you're checking every possible combination. But I don't think you'd use any extra space, so it's just, this is the time complexity. Okay, so what about, how could we do this kind of in a smart way, right? So the more optimized solution would be to go ahead and just get rid of this over here. The more optimized solution would be to do almost like a two-pointer approach. So imagine we had a left pointer that started at the beginning, the first value, which happens to be 1. And then we had a right pointer that happened to start at the end of the array. And remember that I'm putting it on the picture, but ultimately we're going to have them on the first value in the array and the last value of the array. So this is going to go here, and then this is going to go here, right? Hopefully that makes sense. And then what we're going to do is we're going to have the pointers at basically the opposite sides of the array, the starting and the end, and then we're going to calculate the amount of water that it could hold, right? So for these values, it would be, let me do it in a different color than blue so you can see the contrast. It would be this amount of water, right? It would be 1 times whatever this distance is, from 1 to 7, which would be, let's put like the indexes here. 3, 4, 5, 6, 7, 8. So we would do the right pointer to find the width. We would do the right pointer. So this is the height, right? Because even though the right pointer is pointing to a 7, because we can't slant the container, we can't like tip it, we can't put it at an angle, it has to be flat. This 1 is the limiting factor between the right and the left lines, or the right and the left sides of the box, if you can think of that, or the bucket. And then to find the width, we would do the position where right is at, which is currently the 8th position, minus the position that we're at for the left one. So it would be 8 minus 0, so I believe the width would just be 8. So the amount of water that this particular bucket can hold is 8, right? For this combination where we have left here and right here. Okay, great. So next we're gonna have to move our pointers, right? So we're gonna store this in a value, like we'll store it like in a variable called like max, I don't know, max underscore area, or what should we call it? Because I don't want to call it the same. I don't want to call it the same thing as our function name. Let's call it like max amount, max MT, and then this is gonna be set to this, right? Okay, and then let's think of a smart way to move these pointers, right? So we're gonna move these pointers inwards. If the pointers were here, if the pointer was at this value and the right pointer was here, if you think about it, why would we want to move our right pointer? Because our right pointer is at a current higher value, 7. This points to 7, is greater than 1, right? So if we want to keep the theme of trying to maximize the amount of water that we have in the bucket, then wouldn't it be a better idea to move this left value so that because this left value is smaller than this right value, right? So, or this left wall, you can think of this being like a left wall, is smaller than the right wall. This is our limiting factor. So because that's the case, we can just move our left value over here. And let's go ahead and just erase that, put this over here, go back, do that. So that then we'd move our left value here. And we'd continually do this. And we'd calculate the amount. So this happens to be the combination where we get our actual max amount. So we'd get the area of 49. And this we're basically calculating the area, right? So it'd be 49, and then that's going to be our max amount, and then we're going to move our right pointer over because this happens to be our limiting factor. But then we get to a smaller, in the next combination we'd get to a smaller area, right? Because this is a smaller wall than this one. But we're going to keep doing this until our left and right values are equal to each other, because at the point where they're equal to each other, we're going to have went through all the combinations, right? So when left and right are on top of each other, then we can stop our loop, and we know that if they're on top of each other, then we don't even have a width, right? We wouldn't have a bucket. If you think for a bucket, you need like a bottom, right? Then you need a left and a right wall, right? This left and right represents the right and left walls, right? So if our walls were on top of each other like this, then we wouldn't have much of a bucket, right? We couldn't put any water in it. So basically that's when we would stop our loop. I hope this makes sense with kind of the drawings I'm doing. Obviously I'm not doing like expert drawings, but I hope my explanations are making sense. So yeah, and then we'd keep doing that, and then eventually we would just recalculate our amount, like our current area, and we're gonna compare that to our max area. And if the current area is greater than our max area, then we're just gonna reassign our max amount, and then we're just gonna at the very end we're just gonna return the max amount. And yeah, I think that's pretty much it. This is a lot smarter than that brute force solution. So let's go ahead and go over the time and space complexity. So the time, because we're using left and right pointers and we're just going inwards, right? So we're going, the left pointer is going this way and the right pointer is going this way. This is an O of n solution, where n is the amount of elements in our array. Because in the worst case scenario, which is basically going to be every scenario where we have to go through each value in the array. The left and right values are going to, left and right pointers are going through every I guess element in our array. Hopefully that makes sense. And so this is a lot faster. If we go to the big O cheat sheet, this is what our original solution, our brute force solution was. So this is like in the horrible section. It goes up. Basically, the time would take a lot longer as our input size grows. But we made a solution that's a lot faster, so it scales just linearly, I believe it's called. Okay, so yeah, I hope that makes sense. And then our space complexity is constant because we're not using any, the amount of space that we're going to use isn't scaling as our input size grows. Yeah, so I hope that makes sense, and we're going to go ahead and get into the coding solution. All right, so like I said, we're gonna have a left pointer. So a left pointer is gonna start at 0, and then our right pointer is gonna start at the end of the array, so that it basically equates to being the length of the array, which is called height, minus 1, because the length is gonna be 1 more than the index because we start counting from 0. Right. Okay, and then what we're gonna do. We're gonna do while our left pointer is less than our right pointer, which basically equates to what I was saying earlier, that when our left and our right pointer are on top of each other, then this loop would stop, because that means we can't even calculate. There's not much of a bucket if our left and right walls are on top of each other. And what we're gonna say is we're gonna say left wall. You don't have to do it like this, but I like defining variables like this so that it makes more sense than having to just write the operations like all in one line. So the left wall is going to be height. We're going to index into the array. We're going to say left pointer, because this is basically our index value, right? So this left wall is actually equating to the actual values in the array. And we're going to say our right wall is going to be equal to height of right pointer. Great. And then our width, we're gonna try to calculate our width now. Our width is going to be equal to, like I said, it's going to be the right pointer minus the left pointer. Oh, left pointer. Great. So that's our width. And then let's go ahead and calculate our length. Like I said, you can do this on one line, but I like to define our variable so you can just use the variable names instead of writing the operation all out like in one line, where it can be a little confusing to read afterwards. So our length, like I said, our length is going to be, or this is more of like our height, right? But we have our array is called height, so let's just call it length. So our limiting factor, what I was saying was that is a smaller wall, right? So we're going to take the minimum of the left and the right wall, and that's going to be what our length is going to be. Or basically, this is kind of like our height. If you think of, if we're calculating, if we bring this back up, this is kind of going to be like our length, and then this is our width. Because we're doing this in a 2D space, so basically we're just calculating the area of like a rectangle. Okay. So our length is going to be minimum of left pointer and right pointer. Pointer. Great. And then I'm going to say current area is going to be equal to width, or length times width. I guess it doesn't matter which way you would do it, but it's length times width. Okay, and then we've calculated our current area, and actually we missed one step. So out here we're gonna have a variable which is gonna be the area. It's gonna be like the variable that we're going to return. So we're going to say, let's call this like max area to return, and we're going to set this equal to a negative number first because we want this to get overwritten in our loop. We want this on the very first iteration. We want it to get overwritten. So we're going to say if current area is greater than max area to return, then what we're going to do is we're just going to reassign max area to return to be equal to current area, because this is the situation where this current area is greater than this max area, so we want to reassign this variable. And then on the next iteration of the loop, we're going to compare it to that new max area. Hopefully that makes sense. And then now we need to, if we left this how it was, then we'd have an infinite loop. We have to do our pointer movement, right? Our left and our right pointer movement. So we're going to say if left wall, like I said, if left wall is less than the right wall, then it wouldn't make any sense. It wouldn't make any sense to move the right wall to the left, right? If in this situation where our left was here, our left pointer, LP, and our right pointer was here, then it wouldn't make much sense if we moved this right pointer over, because this is already our limiting factor. So we want to maximize our amount of area, right? So we're going to say left wall, if left wall is less than right wall, sorry, I have the hiccups, then we're going to say, we're going to move our left pointer over. We're going to just left pointer plus equals 1. And then else, in the other situation, then we can just move our right pointer. And it's not plus equals, it's minus equals 1, because our right pointer happens to start at the end of the array. So we're going to move that inwards. So the pointers are moving inwards towards each other. Great, and then that should handle that, and then we could just return max area to return. Great. See if I made any mistakes. Give me 1 second to try to figure this out so I don't extend the recording. Okay, so after staring at it for a little bit, I made a slight mistake. So this length, or which is basically like our height, if you think about it, we're not using the pointer values. We're using the actual integers in the array. So instead of pointer, I used the wrong variable. So this should be left wall and right wall. So we're taking the minimum of the left and the right wall. So I hope that fixes it. Great. Yeah, so that's that. Thanks for watching. I think I went over the time and space. So again, this is a big O of n solution with a constant, or a big O of 1 space complexity. Great. Thanks for watching.